Hello friends, this is Jim with Science Talk. I have a couple of quick stories that I wish to share with you. But before I do so, please let me remind you to please subscribe to my channel. Please share my videos with others and have them subscribe. Hit the bell so that you know when I drop a video. And please support the work that I do. I bring you important information that society needs as we start dealing with the consequences of not only the changing climate, but other information of ongoing research in other areas that I like to bring you from time to time. You can support my work by going to patreon.com/Science Talk with Jim Massa, and for as little as $3 a month or more, if you're so inclined, I appreciate it if you do, you can support the work that I do. So, you've heard me mention this before, but some more stories to illustrate. More downpours, increase in heaviest precipitation events. Now, as I have reported to you, that with climate change, we're going to get hotter conditions, wet areas will become wetter, dry areas will become drier. My next video, I'll talk about the spreading Sahara. And also, rivers will run higher and maybe overflow their banks, creating more flooding situations. Rivers continue to swell in the Ohio and Mississippi valleys. As an example, 10 inches of rainfall fell in Arkansas and Louisiana recently. While individual weather patterns may allow for heavy rain, the heaviest of this precipitation is increasing as the world warms from climate change. Why is that? Basically, a warmer world will supercharge the water cycle, leading to heavier precipitation because a warmer atmosphere creates more evaporation. You increase the temperature of the air, it can hold more water content, more water vapor. More water vapor means more precipitation will eventually come down. For every 1 degree Fahrenheit of warming, the saturation level is increased by about 4%. In other words, you increase the air temperature by 1 degree Fahrenheit, it can now hold 4% more water vapor. With more water evaporating into the atmosphere, there's more available to condense into precipitation, and it's coming down in bigger downpours or heavy snow events. So when you have, and I'm going to be blunt here, I ain't going to sugarcoat this, when you have idiots like Senator James Inhofe of Oklahoma, he brings a snowball onto the Senate floor and says, oh, there's no global warming. Well, he basically demonstrated his complete lack of understanding of any scientific concepts and principles. It's snowing more because there's more moisture in the air. More moisture in the air means it's warmer. It comes down as snow because at that time of year, the northern hemisphere is tilted away from the sun. And these guys get determined what science projects are going to fund. How insane is that? All right, rant over. Okay, so it really is frustrating. It just frustrates me to no end. So, the national map shows where this change has been most dramatic, indicating precipitation in the heaviest 1% of rainfall days is getting heavier. Meaning heavy rainfalls are going to become heavier rainfalls becoming extreme events, is basically what that says. So, science has been documenting increased heavier precipitation related to changes in the climate for quite a few decades now. But now they have the ability to analyze the role of climate change in individual extreme rainfall events. There is a team called the World Weather Attribution Team. It indicated the rain from Hurricane Harvey that hit Texas was about 3 times more likely and 15% more intense due to climate change. In other words, if the planet was not warming, it would not have been as bad, as devastating as it was. That's what this is saying. Another World Weather Attribution analysis found that the Louisiana deluge of August 2016 was about 10% heavier because of climate change. Even in the absence of urban development, where there is more rain runoff, heavy rain will still lead to more flooding because the ground cannot absorb it. It overwhelms the ground and so it just runs off. Ground can't absorb it, and even when the ground, after so much rain, the ground is already saturated, so even if it could, it cannot absorb any more water, so it's all going to run off. What does this mean? Extreme flooding becomes much more common. And if you got property, I love these people who build their homes in flood zones, floodplains. Okay, guess what? You're going to have more property damage. So, and of course, the insurance companies will have field days with this and so on. That's a whole other deal and what it does to property values. I'm basically, yes, those are the implications that people need to be aware of. I'm reporting the science. Although I will put this number out for you. Damage from the 2016 Louisiana floods was 10.4 billion, would it be, and total 125 billion would it be from Harvey. Okay, so there's that story. I want to now switch gears and talk about the arid West. So going from getting soaked to drying out. America's arid West starts to move eastward. America's arid West is growing larger. The arid zone of the U.S. is spreading eastwards. Guess what? Thanks to you-know-what, climate change. So basically, after decades of the climate changing, the boundary between the dry West and where we started getting into the fertile farmlands of the eastern states, or even the plain states, is changing. It's being replaced by arid ground. Now, there's a couple factors involved here. For example, the Oglala water table has been almost sucked dry, so to the point that it's now brine water being pulled up, which is not good for crops. So when that starts happening, the ground above it will start drying out. So that's another factor with the That's why it is now the switch to going to drip irrigation in an attempt to minimize further water loss and further water drainage. So in the case of one of these arbitrary landmarks, the 100th meridian is one of those astronomically determined lines that emerge from what researchers call psychogeography. Okay. Psycho. So it's basically, sort of something in the mind as to where we're going to set boundaries. Okay. This is sort of like, the 38th parallel between the Koreas. Okay, the 38th parallel. Could have been the 37th, the 39th, or the 38.5 parallel. You get the idea. Okay. About 140 years ago, this line, this demarcation, was first noted. Okay. A geologist, pioneering geologist and surveyor, identified a divide running from north to south between land that received ample rainfall and soils in the so-called rain shadow of the Rockies that could be classified as arid. And as it so turned out, it could conveniently be measured as 100 degrees west of Greenwich in the UK. Greenwich, the UK, is 0 degrees longitude. Okay? In 2 papers in the journal Earth Interactions, researchers have taken a closer look at the reality of this dividing line and the changing nature of the U.S. landscape as a consequence of things happening to the climate. And they found some interesting things. They confirmed that in the 140 years since the first observations of that divide, the line through North and South Dakota, Nebraska, Kansas, Oklahoma, and Texas has shifted eastwards by 140 miles. It's almost like a mile per year. Basically, in Texas, this is a shift from Abilene to Fort Worth. So who was this pioneering geologist? I don't know if any of you might have guessed him, if you know anything about the history of the West. But it was John Wesley Powell. Okay? He noted the transformation. Okay? He was the one who made these observations. So, west of the line, okay, what would you see happening west of the line? Lands are getting more arid. There are fewer farms. To the east, most of the crop is maize, corn. Corn likes a lot of water. So as this demarcation moves east and east, it's going to be less suitable to grow corn. And corn is a major crop, not just for human consumption, but for livestock, and in the cases where they get the ethanol for, for the fuels and so on. So this is going to have ramifications on that accord right there. Now, on the western side, you're going to probably see more wheat being grown because wheat is more resistant to dry conditions. So the researchers predict that dry lands will continue to move eastward as global temperatures continue to rise, and eventually this can trigger large-scale changes in the sense that you start changing the ecosystem. Plus you start changing what it means for human growing food, agriculture, and so forth. So we got wet stuff going on, we got dry stuff going on. And this is what's happening. You're going to see these extreme swings, extreme shifts in the extreme. That's what I wanted to say. And the system has been perturbed. So planet Earth is trying to find this new equilibrium condition. But because we keep perturbing the system, the equilibrium position is not settled upon. It keeps being disrupted. So this is why we start seeing crazy extremes. It could be 18 degrees and drop 10 inches of snow in Boston. Then the next day it's 58 degrees and it all melts. You can go from wet to dry and so on. Wet areas becoming more wet. Dry areas becoming more dry even so. So there are consequences. And now when we start seeing that where we live is being affected, storm surges and so on, wave action pounding away, or our food supply is being affected, the consequences are coming home to roost. Thank you for your time. Please share this video. Please support my work.